That's a good point regarding the panels. You know, they're getting more efficient, definitely, but they're getting longer too. I think I
Yeah,
saw there was a panel that was almost 2.5 meters long. I think maybe it was one of the neutrino panels, or I can't quite recall. But where does it, like, at what point? What's the maximum? You probably can't answer this question because you haven't run the numbers, but
should
at some point we need three rails, right, as a
yeah
minimum. When are we
yeah
going to reach that
four,
point, do you think?
even four.
Even four, yeah.
Yes, so especially on tilt installations that are outside of what the standards will provide you with an approach. So this is interesting for me to explain to customers. When you have a flush installation, you only require an exclusion zone. So what is an exclusion zone? From the edge of the roof inwards, you have an area that you cannot install due to safety reasons.
Mhm.
This is because we calculate upwind and downwind forces, and we calculate an exclusion zone. So it's pretty easy for flush installations. For tilt installations, you have to subdivide the roof into four areas, which are internal, intermediate, edge, and corners. My point is that sometimes we have had installations that on corners and edge zones, we required four rails per panel. And this would decrease once you go towards the center of the roof. In that example, we had on the intermediate areas, three rails per panel and only two rails per panel on the internal zones. If anyone is interested in knowing why, it is because on the central areas, the surrounding panels will act as a shielding, so it would not be subject to the same pressures, whereas the corners and edge zones are prone to receive the frontal wind and a higher pressure, a resulting higher pressure.
Okay, so that's interesting what you said about the exclusion zones, right? So you have exclusion zones on a flush install.
That's correct.
Do you have exclusion zones on a tilt install?
Well, the standards will. It's sometimes very subjective on this because you have a safety distance that you have to keep away from the ridge
Mm-hmm.
of gable roofs, which
So just on that, just on the ridge, right? So this is the roof, yeah,
yes, that's correct. So
and the
this is the
ridge is
roof,
up here,
the crest, the
the
crest of the roof.
crest. Okay, so you're saying you need to keep away from the crest.
But there is a minimal distance, so it's 2s.
Okay,
What is s? S is the distance. If we have an inclined plane, let's say, I love using examples to illustrate a point. So if this is the roof of your house, right? This would be the crest, the ridge. Obviously, if we're looking at one direction, it will be like this. So that's the ridge of the roof right there. What is S? S is the distance in which you install the panel, the distance between the top of the roof parallel with the underlying of the panel. That is S.
okay.
So
So the
normally,
distance between the roof, like if it's a corrugated roof, for example, it's the distance between the top of the corrugation and the
yeah,
bottom of the frame of the panel. That's what you're talking
that's
about.
correct.
Okay,
That's correct.
sure.
So according to the CEC, you have a minimum safe distance that you have to comply with, and it is intended to limit the amount of stress that you put onto that panel. Obviously, when you are closer to the ridge, the wind will break up in a more frontal direction with nothing to shield it.
Okay,
So
so
it's a precaution, and yeah,
I've got
I
a
think it's
question. I've got a question for
smart
you.
approach.
I've got a question for
Shoot.
you. Right.
All right.
So this actually was raised to me by somebody on one of the Facebook groups the other day. I think
Mm-hmm.
it was Facebook. Anyway, so it was a gable roof. That's what it's
Okay.
called.
Yep.
So like this.
Correct.
Okay, so that's the roof. So they wanted to put flush panels here, right? So running panels flush up this side of the roof.
Yep.
And then, so this is the north facing side and this is the south facing side, right?
Okay.
So they wanted to run panels up the roof, and so that it all looks continuous, and then over the top. And then on this top bit here, this is a tilt leg that comes down onto this side of the roof, right? So they could fit another row of panels. Could they do that under the Australian standards? That's my question.
I think they couldn't. I don't think it's compliant.
Okay. So there's certain things that you can't engineer your way around.
There are some limitations. Yes, that's correct. That's correct. There are some limitations that you have to just be in line with the standards. It's as a general practice.
Okay. And you mentioned earlier, so we were talking about, multiple rails, 2 rails, 3 rails, 4 rails, 5 rails, why not? That's something now that, it's been there for a while, but we added that onto the Easy Quote tool, didn't we?
Yes, we have actually. There is a section where you can play with the type of amount of rails, but it will be more intended for the generic. In the engineering department, we can play around with the type of rails and we select, and that's where it gets very interesting. That's a part of the side of the job where you start to calculate different deflections on different rails, and you can recommend, okay, look, we require more robust rail, or we require another eco rail.
Okay, but in the generic certs, we've accommodated for rails more than 2. So in the generic certs, you can use 3 rails or 4 rails in certain cases, in order to meet the spacings of the purlin spacings, for example.
So if there's a simple way around it that I think everyone can understand as a simple fact. If you see a panel on the underneath the panel, you would have 2 rails running, and so the weight of the panel and the uplift forces will be distributed only on 2 rails. Mm-hmm. If you add a 3rd rail or a 4th rail, you would be distributing the loads to more elements. Mm-hmm. So it's a more efficient way of weight distribution and load distribution.